Good afternoon, everyone. Thank you for joining us today in this session, Big Data at Scale. My name is Gargi Singh Chhatwal, and I'm an Associate Solutions Architect with Amazon Web Services. With me today presenting is also Dr. Nitin Naik. He is the Chief Technology Officer at US Census Bureau, as well as Nanda Sreenivasan, Senior Solutions Architect at Amazon Web Services. I hope all of you had a nice, fulfilling lunch and is similarly energetic as I am. And with that, let's dive deep straight into it. So today we are going to cover why big data. If you are an enterprise and you're dealing with your legacy applications or you're creating new ones, why does big data matter to you? Then we are going to see how to do big data processing on AWS, which services you can utilize on AWS to create your enterprise application. Next, I would like to invite Nanda to talk about a few of the architectural patterns which we see in our customer space, as well as I would like to invite Dr. Nitin Naik to talk about how US Census is utilizing AWS services to create their enterprise data lake. So why big data? I'm a really curious person. To feed my curiosity, I like to read a lot. So in one of those reading sprints, which I call them, I came across a study known by International Data Corporation, or IDC, which talks about the total size of the digital universe. So think about it as every digital platform that you know, every device that you know, every data that you know about. By 2016, it was 16.1 zettabyte. And by the time we reach 2025, it is estimated to reach around 163 zettabyte. Just to give you a perspective of how much 1 zettabyte is, I think all of you in the room are aware of a 1 terabyte hard disk. Now imagine 1 billion of those. So when you stack them all together, you might reach somewhere near around 1 zettabyte. So by the time we reach 2025, think about 163 billion hard disks. Where are you going to keep them? Is it going to be a room location? It could be your data warehouse, but how much that can scale? Or is it going to be something else? So if I'm an enterprise and I'm either remodifying my legacy application or creating a new application from the scratch, I would think, am I architected to achieve this scale? Am I? And it's not just about the velocity. It's also about the velocity. It's not just about the volume. It's also about the velocity and the variety with which we are producing this data and consuming this data. Think about your legacy applications, which you used to have, and now we have IoT devices ever present in all phases of life. It could be the Fitbits you wear when you work out. It could be the sensors which are in your cars when you move around. For example, there are a lot of cars right now which are dealing with a lot of different sensors and different type of data which is being produced. So if I am an enterprise, I would have those questions in my mind. Am I architected to handle this volume, velocity, and variety of this data as well? So now let's talk about how you can handle all these three factors by coming onto AWS and then using the AWS services. My time working with big data and as a big data engineer and then at AWS as well, I've always believed that a successful big data application follows a particular trend. And then this trend is nothing but an actual pipeline. And it starts with recognizing what data you have. And at the end of this pipeline are the answers which you are looking for. Now, these answers could vary depending upon what are you looking for. This pipeline has multiple components to it, starting with how are you going to collect this data, recognizing which applications are producing this data. The next part of this pipeline is to recognize how are you going to store this data, because the data could be in different shapes, sizes, formats, structures. It could be anything which you are looking for. The next part of this pipeline is to recognize how are you going to process and analyze this data. Do you want to do some kind of ETL on this? Do you want to do some kind of conversions on this? Or do you want to do some basic analysis? This step can repeat itself based on the fact that how you want your data to be in a shape and format at the end of this pipeline, which is how you consume the data. So these three steps, a lot of time they repeat themselves based on the fact that how you want to reshape your data and how you want to consume it at the end. Now let's just talk about each of these components one by one and see how you can achieve that on top of AWS. Starting off with the collect phase. So in this phase, if you are an enterprise, you are dealing with some kind of application. It could be web applications, it could be mobile applications, it could be enterprise applications, which are running the core of your business. If you are an enterprise, you also have requirements to store logging information. It could be based off the auditing purposes. It could be because of networking purposes, security purposes, monitoring purposes, and whatnot. If you look at the services which AWS offers, you can utilize AWS CloudTrail, which is our logging and auditing service. If you're running something on top of AWS, utilizing AWS CloudTrail, you can log each and every request which is ever made on the AWS platform or the AWS resources. You can also use Amazon CloudWatch to monitor all the resources which are running on top of your AWS platform. We also support open source such as Log4j, Logstash, and Flume. I mentioned earlier about IoT devices and their presence nowadays. So if you have applications which are producing these kind of streams, or if you have devices within your applications which are producing these streams, you can utilize AWS IoT suite of solutions to deal with those kind of scenarios as well. That being said, you know how you're going to collect this data, but how are you going to move the data into AWS is a big question. Now, this data movement could be either that you're moving the data into AWS, or you have a hybrid model where your on-premise systems are talking with AWS or vice versa. We have different suite of services that you can utilize to do this and achieve this as well, starting with Amazon Kinesis Firehose. And Amazon Kinesis is a really interesting service. You will see it different times within this pipeline itself. I'm going to repeat Amazon Kinesis multiple times. Amazon Kinesis Firehose allows you to seamlessly load massive amounts of data directly into a storage service. Or if you are an enterprise, you might have situations where you want to run some of your applications on-prem and some of your applications move to the AWS cloud. So for that, you can utilize AWS Direct Connect, which is a dedicated pipe between your on-prem systems, your data centers, and the AWS environment. But what happens when the data movement is too big? It's too big to be going over the internet or even Direct Connect. Say it's terabyte or hundreds of terabytes of data or petabyte of data that you want to move over. So for those kind of scenarios, you can utilize AWS Snowball. AWS Snowball is an actual physical device which we send to your location. You connect it in your own data centers, you copy the data over, and then you send it back to us, where we connect it on our premise systems and then load it up into Amazon S3, which is our storage service. But what if you have scenarios where you want to run file formats such as NFS, iSCSI, or other kind of storage? To seamlessly integrate your on-premise systems and the AWS storage, you can utilize AWS Storage Gateway, which allows you to handle those kind of file formats such as NFS or iSCSI. Now that we have talked about how you can collect the data and how you can move the data into AWS, the next question is, how are you going to save this data? In which structures, in which format are you going to save this data so that you're able to process it onwards? When I talk about traditional enterprises, you see that they are dealing with a lot of databases. Now, this can be in the realm of relational databases. It could be in the realm of non-relational databases. So for each of those, we have multiple services, such as Amazon Relational Database Service. It's a fully managed service. You don't have to take care of underlying infrastructure. You don't have to take care of the managing, the patching, and the software updates. If you are dealing with non-relational database, such as MongoDB, we have a fully managed service known as Amazon DynamoDB, which helps you achieve that as well. But if you're an enterprise, you're not just going to handle databases. There is going to be a lot of different kind of data. It could be multimedia files. It could be images. It could be text files. It could be some other kind of blob. So for all that kind of storage, you can utilize Amazon S3, which is a simple storage service. Amazon S3 is highly scalable. You don't have a maximum limit of how much you can scale it. It's massively scalable. It offers you 11 nines of durability. So imagine that you're going to lose one file in about 10 million years. That being said, if I go back to the devices segment, which I was talking about earlier, if you have some kind of applications which are generating streaming data, you can utilize the different services which we have to offer, such as Amazon Kinesis Firehose, Amazon Kinesis Streams, DynamoDB tables, which allow your non-relational database tables, such as MongoDB or something like that, and converts those non-relational tables into a streaming structure where you can directly stream from the tables itself. We also support open source softwares, such as Apache Kafka, which you can run on top of EC2, which is our Elastic Cloud Compute Service. Now that we have realized how are you going to save this data, how are you going to collect this data, the next part of the pipeline is to recognize how are you going to do the processing and analyzing of this data. What kind of different processes you can do. And we believe that there are 4 major things that you always do with your data, starting with data enrichment. You can add multiple data sets to one another to enrich the data so that you can see what you have not yet seen in your data itself. We have a suite of different services which support this as well, such as Amazon EMR, which is our Elastic MapReduce service, Amazon Kinesis, AWS Glue. You can do some kind of analysis. It could be batch analysis, it could be streaming analysis, it could be interactive analysis as well. And we have a bunch of different services that you can utilize to achieve that as well. If I go into the realm of ETL, which is extract, transform, and load, say you want to convert one of your JSON files into Parquet, or if you want to convert your CSV files into something else, we have a bunch of different services which help you do that as well. One other thing I want to talk to you about today is a concept of data lake. So let's say if you are an organization which is doing some kind of genomic research, one part of your scientific group sees the data in a different way than the other part of your scientific group. You don't want to create data silos and reiterate the work which you have already done. You don't want to ever go back and reinvent the wheel, the data which is already present. So for that, you can utilize a bunch of different services which we have to create your own data lake, keeping all the data at a single location so that multiple parts of your organization can view the data from the same place without having to reinvent the wheel again as well. Now I'm going to talk about a few of these services in details, starting with Amazon EMR, which is our Elastic MapReduce service. It's a fully managed Hadoop cluster framework. It supports a variety of big data frameworks such as Hive, Impala, Spark, Presto, and many more. We see a lot of our federal agencies utilizing EMR in their production workloads where they run their Apache Spark or Hive workloads on top of AWS. What makes EMR different is the fact that it comes with something called as EMR-FS, which is Elastic MapReduce file system that allows EMR to efficiently and securely use Amazon S3 as the underlying storage. So you don't have to worry about creating your HDFS storage underneath your clusters anymore. Rather, you can stream the data directly from S3 into your clusters to process it. It's natively integrated with Amazon S3, RDS, Redshift, and any other JDBC-compliant data store. But if you're an organization, you are not just going to have the need for distributed computing. You might want to run some kind of structured statistical analysis. You might want to go into the realm of data warehousing. So for that, you can utilize a service called as Amazon Redshift, which is our fully managed relational data warehousing service. It's massively parallel. It's petabyte scale. So you don't have to worry about the scale as your data is increasing or as you're collecting more and more of that data. Amazon Redshift supports data compression, so it reduces your IOs massively, so you get more insights out of the same amount of data you already have. It also supports columnar data storage, and it is designed for scale. If you look at the pricing model of Amazon Redshift, you'll notice that it's 1/10 the cost of traditional data warehousing solutions, commercial off-the-shelf data warehousing solutions. And it's only $1,000 per terabyte per year. But for an enterprise, it's OK to have distributed computing. It's OK to have data warehousing solutions. But what if you want to analyze the data as it's coming in? You don't want to wait too much to analyze this data or even start up your own clusters and then feed the data into those clusters and then do some kind of analysis. So for that, we have a service known as Amazon Kinesis. Amazon Kinesis is a managed service for real-time big data processing. It has 3 different variants to it, the first one being Amazon Kinesis Streams. It allows you to create the producer-consumer kind of streams wherein the data which has been produced, you can consume it on the go itself. You don't have to worry about the underlying infrastructure or how it's going to match the throughput of the streams which is coming in, as you can elastically add and remove shards within Amazon Kinesis Streams. But what if you just don't want to analyze it, rather keep it somewhere so that you can do some other statistical analysis at a later point of time? For that, you can use Amazon Kinesis Firehose that allows you to massively load large amount of data into our storage services such as Amazon S3 or Redshift. That being said, if you want to do some kind of analysis, say you are an enterprise and you want to see and create some kind of charts and graphs or do some kind of data manipulation of the data itself as it's coming in, you can utilize Kinesis Analytics, which allows you to do SQL-type queries on the data as it comes in. You don't have to wait anymore to do those kind of analysis as well. Say you keep all the data in Amazon S3. You have achieved distributed computing. You have achieved data warehousing capabilities. And you are also dealing with the data as it comes in. But what if I don't want to create my clusters anymore? I want to run some kind of data manipulation query or data visualization query without creating my own clusters. So for that, you can utilize Amazon Athena, which is our interactive query service that allows you to directly query the underlying storage, which is Amazon S3, without ever having to create any infrastructure. It's completely serverless, so you don't have any infrastructure or resources to manage. It allows schema on read. This is a very interesting thing. So say if you are a financial enterprise customer and you have the market data coming in from various different sources, one part of your analyst group can see the data in a different way than the other part of the group. You don't want to reiterate on the traditional silos of data. Rather, you can utilize Amazon Athena to view the same data in many different shapes and forms. That is the power of Amazon Athena, which allows you to do the schema on read. Next service which I want to talk to you about today is Amazon Glue. It is our data warehousing. And when you're doing data warehousing, you create catalogs. And when you are in the realm of going into data lake, you need those catalogs because you want to differentiate between what is present within your data warehouse. Amazon Glue allows you to do that. It allows you to create data catalogs. It creates Hive Metastore compatible data catalogs, which has enhanced functionality. There's something called as AWS Glue crawlers. They understand the underlying data which you have in your S3 buckets and automatically extracts the metadata out of it, creates a catalog, and saves it in AWS Glue so that you can use it again and again without having to create the whole process all over again. Another part of AWS Glue is that it's a managed transformation engine. It auto-generates the ETL code. Now you can go into the AWS console, click a few buttons, and you will have an ETL code ready for you. It's built on top of open frameworks, such as Python and Spark, so you can make modifications within that code itself. You are not restricted, or you're not bound to the code which is being created. Another important service or part of AWS Glue is that it's a job scheduler. Say you want to run those ETL jobs every hour, every day, every month. You can do that by creating automatically repeatable jobs using the AWS Glue job scheduler. And you don't have to worry about how the data is going to be matched in terms of the throughput it takes or how much data you have. It's massively parallel and it's massively scalable, and you don't have to worry about how the infrastructure is going to scale as your data is increasing. Also, it's natively integrated with Amazon S3, EMR, and many other AWS services as well. Oops. Sorry. Now that we have talked about how you can do the collect, process, and store phase, the last important aspect is how are you going to make your data consumable? Now, it could be various different formats. You can either create some app and services and expose them using APIs, or you can do some kind of analysis or visualizations using traditional BI tools, and one such tool is Amazon QuickSight. It's completely serverless. You don't have to manage any clusters. It's a pay-as-you-go model, so you're only paying for what you use. We also support open source, such as Kibana, and partner tools, such as MicroStrategy. What if you want to do some kind of machine learning on top of this data which you just processed? Say you converted your JSON files into a Parquet format, and now you want to do some kind of statistical analysis or some kind of machine learning. You can do that using open source such as Apache Zeppelin or IPython notebooks on top of AWS. as well. So putting together everything, summarizing what I talked about, starting from how are you going to collect this data? It could be different applications. It could be different logging information that you are saving, say for auditing purposes when you are an enterprise, or for security and networking purposes, or it could be data which is produced by streams. Next, we talked about how are you going to save this data. It could be traditional databases, which you might want to utilize. It could be any kind of file structure, multimedia files, audio, images, whatnot. Or it could be streams that you want to save as well. Next, we saw how and what kind of different processes and analysis you can run on top of this data. It could be streaming analysis, it could be interactive analysis, or it could be some kind of machine learning as well. And at the end, we saw how you can make this data consumable. It could be some kind of an API or an app and service which you're exposing. It could be some kind of analysis or visualization you can do by using some traditional BI tools or using Amazon QuickSight, which is our native business intelligence tool. And also, you can do some kind of machine learning as well using open source software or any other software as well. So it does not matter how much data you are dealing with. It does not matter what kind of volume, velocity, or variety you are dealing with. You can use and mix and match a bunch of these services to create your next enterprise application at scale using AWS. And now I would like to invite Nanda to talk about a few of the architectural patterns which we see in our customer space.
Good afternoon, everyone. Thanks, Gargi, for introducing me. So I'm going to focus on, whatever the Gargi talked about on the AWS Big Data Services and how our customers are using it, how some of the mission-critical applications been using some of the architectures and best practices. I'm not going to call out not all of them, but I'm going to take some few very interesting architectural patterns. The one I wanted to talk first is the how to build an event-driven batch analytics on AWS, right? Typically, you have an enterprise, agencies, they produce data from various formats, they store in various data sources. For example, you have traditional, like on-prem database, you have a cloud database, it's RDS, and we also store data from various applications like log files and JSON files and whatnot. They all can be ingested and processed. As Gargi said, all this data is produced in a different speed. That means that you may have to process them in a different speed as well. Not all of them can go in a batch process, right? So how do we combine and make it kind of event-driven where your enterprises can look for business events and then they kick off some of the batch process using the EMR and all stuff. We'll talk about it. For the event-driven programming, so we have AWS Lambda. The AWS Lambda, if you all know, or if you don't know, AWS Lambda is it allows the developers to develop a piece of code that can be executed serverless manner, meaning that so you read a piece of code as a function, like a Java function or a Python or like a .NET or a Node.js. So that means that what it means, the power is you have a wide variety of developers, wide variety of enterprise applications is developed using different formats and platforms. So you all can take what your workforce is, so they can kind of reuse what you have assets, bring them into your data analytical platform, right? And typically what we say, right, all of this data can be moved into an S3, and also the Lambda can be kind of integrated with the event-driven fashion where S3 can emit a lot of different like events. For example, it can emit an event on while the file is created, while the file is updated, or while it's deleted. So you can imagine how creative you all can be to use a Lambda to process some kind of any type of process you can do, right? For example, as and when there's a data comes in from various sources on S3, then you can kick off some Lambda program that can, for example, staging area to kind of a pre-processing area where you can do some kind of input validations, data conversions, whatnot. You can run those algorithms there, and then once you have some kind of a staging area into pre-processing area, then you can figure out what kind of data analytical jobs you want to run and what fashion you want to run, right? Or you want to combine both. For example, you wanted to have some of the very heavy lifting move into like a traditional Hadoop clusters. Some of them can be combination of Hadoop and as well as like Lambda, right? For example, as soon there's a pre-processing data area, the file comes in, you can kick off series of Lambda functions. And also, because it's stateless, you could also create some kind of a state management to figure out, what's going on with your processing engines by kind of bringing in a storage area where it like RDS or something. We can also manage it. And then once you have figured out you want to kick off heavy lifting processing using EMR. EMR is an elastic MapReduce that runs the Hive and Hadoop and Spark clusters, and also it also supports a lot of open source big data frameworks. And also finally, it can all end into your Redshift. That's the kind of a traditional downstream data warehousing area where you can like park them for further analytical purpose, right? This is kind of a very interesting. I wanted to talk because it gives the power of cloud, right? The power of cloud from AWS side is the S3 flexibility and scale, and also its innovation about the emitting the events where you don't have it in a traditional storage area, and also you can use Lambda that can reuse all your assets to bring in a very powerful data platform that you can create. Right now, I can jump, and also one thing is because it's stateless, I wanted to highlight this. We have AWS IAM, which is called Identity and Access Management. That's our kind of a core security principle where it allows you to give user access to the data and user access control, also role-based access controls on your data, plus data security. And also, if you look at the down, it's like a CloudWatch. The CloudWatch is our monitoring tool that can monitor all of our AWS services, as well as you can write your own custom logging. You can plug into CloudWatch, so you can have one dashboard that can monitor what's going on in your platform, right? Now let's move into one more interesting pattern before I go to other topics. You all heard about real-time and real-time batch processing, real-time processing as well as batch analytics. For example, you have your data sources comes in many different formats. Now the modern data source is called data streaming. So there are a lot of enterprises start producing data in a very real-time fashion. Right? They also figured out they wanted to process the data in a real time as well. For example, think of it like a scenario where your enterprise is producing data like market research data, where you are collecting the data like every minute or every second, and you wanted to do a couple of things, right? Not just one type of analytics. So what we are offering from AWS side is called Amazon Kinesis. Amazon Kinesis is a platform where it allows you to stream the data from many different data sources. We have the Kinesis client library that you can integrate with your programming construct, so that can make that program as like a data producing stream. And then that can also called Kinesis Firehouse. The Kinesis Firehouse is a serverless, highly scalable data platform where it can move the data from one source of data source into different data sources. For example, it also natively supports all of our AWS services, for example, S3 or SQS or RDS or DynamoDB. So depending on the use case, whatever you want to do, you can do. Here, I want to highlight two different things here. If you look at on the right side, it's like traditional data sources, and also the streaming data comes in. They all can be plugged into like Kinesis Firehouse. The Kinesis Firehouse can move the data into different like destinations based on what your use case is. For example, if you have a use case where you want to do data analytics like a batch processing way, then you can move them into an S3 bucket. It's kind of a traditional way of doing it. Then that can kick off, or or like a Hadoop or something you can run on top of it using EMR. Then if you look at the bottom side of the picture where we have the speed layer, what we call it. So you can do Kinesis analytics as a platform to do the real-time processing of the data using Kinesis analytics. And then again, further it can move into different set of output areas by using Kinesis Firehouse. This all can happen in the bottom line. The bottom layer, if you look at it, all of them are serverless. You don't maintain any of your infrastructure. We make it for you. Also, the Kinesis Firehouse and the Kinesis analytics, it's basically it scales by itself. If you have a throughput, automatically it adjusts it, and like sorts the data and whatnot. And then finally, you can loop them into any of your BI tools, via like Athena is one example here. You can also bring the Redshift and any of your databases to pull in. And then our Amazon QuickSight is our BI tool, and then you can plug in with any other BI tool with that that you typically use it. And then I wanted to move into like a kind of a traditional, data-centric, applications like data warehouse. You all know all the enterprises, one form or the other, you all have the data warehousing solution, right? From AWS side, we have a Redshift. Redshift is a petabyte scale data warehousing solution on AWS. And here, if you look at it, there's a petabyte scale. So if you have terabytes of data, typically stored in data warehouse, that's great. What happens if you have data growing, ever growing, and you have like exabyte of scale data? So what the Redshift spectrum is giving is basically the power of taking the Redshift, which is the petabyte scale highly parallel hardware, and then you can take advantage of S3, which is highly scalable, ever-growing data storage, which you can create for your applications. Then you combine them both, wherein you write a piece of, like your SQL queries on Redshift that can directly go against your data storage. But here in this case, S3 is where all your data is stored, and then your Redshift is where you'll be using to interface to interact with the data, right? And then you can use any of the BI tools. Now I'm going to talk one of the other interesting data pattern is the data lake, which is very common and popular these days. Everyone wants to talk about data lake. So in AWS, we have data lake concept, but the center of universe starts with S3. And then we have AWS Glue. I will talk about it as usual. So you have all your data coming from, all kind of different data sources can land the data into an S3 bucket. That's kind of a center of the universe for your data lake. And then you can use AWS Glue. That's AWS Glue is a kind of a cataloging tool. If you look at data lake, what the characteristic is, you need to catalog the data. You need to search the data. You need to find the data. Also, you have to secure the data by using role-based access control, right? So all of them is provided by the AWS Glue using AWS Glue catalog as well as AWS Glue crawlers. The crawler is a kind of, it crawls your data, and then it creates an inline data model that can be used for their applications. If you're looking at Athena, EMR, Redshift Spectrum, they all can access your S3 data stored in S3 via Glue. So that gives you the search capability of the data, organize the data, as well as like role-based access control of the data, right? If you look at the Glue, so the Glue ETL also you can run it. The Glue also helps you to run some kind of a batch process and managing those batch process that's happening on top of data lake, right? So with that, I'm going to introduce Dr. Nitin Naik, CTO of US Census Bureau, to talk about how US Census is using the AWS to build data lake on AWS. Thank you.
Thanks, Gargi and Nanda. So they set the stage for me. Now the question is, how many of you folks are enterprise managers of data centers? Okay, a few of you. So the question is, what do you do with this from an enterprise perspective? Need to give you a little context. So I know every one of you is aware of the census. Well, we have been collecting and disseminating data since World War II, and we are part of the Constitution. So we are required to collect data once every 10 years of the population. But besides that, we do a lot of other data collection. We collect about another 110, 115 surveys, besides the census, which we conduct once every 10 years. And so we put out different forms. We also do work for other agencies. There's a huge, everyone who's working with data, you're saying, hey, there's data being collected all over the place. Yes, we call that administrative records, because that is not the official collection. That was collected somewhere else. It's considered third-party data. So what are people looking for? Well, we produce indicators. We produce population estimates. And those same estimates, those indicators, are used not only by the federal government to make decisions on populations, voting rights, all those sort of things, but they are also being used by the private sector. Walmart uses it. Starbucks uses it. They're trying to figure out where to open units. Okay? The stock market is using our business data. We put out economic indicators second Tuesday of every month, and then the stock market uses that data to figure out where things are going. Well, one of the big problems they have is the fact that they want us to produce faster. They want us to produce more data which is higher quality, which gives them more information. So that is part of the change that is taking place from the customer standpoint. So big data is a buzzword. It's now in the market. Census has been in big data for a long time. We've been going after it. What we are trying to do now is say, okay, how can we enhance the current survey methodology? How can we reduce the respondent burden? By the way, how many of you fill out every survey you get in the mail? Okay, well, we are trying our best. We are trying our best to reduce the burden on you folks. Okay, we are trying to optimize the data quality process. We are trying to figure out how can we make sure that the data quality improves as much as possible. And then I mentioned about the timeliness. Data, if our products are old, outdated data, it's not useful because the world is changing fast. The other part is making sure we have granularity. We have certain amount of detail and then better information for unique situations. So the problem statement, so Nanda and Gargi presented the tools. So an organization like mine says, okay, what are we trying to achieve? How are we trying to use these capabilities? What is going to happen for us? So being a CTO, I always say, what is the business problem statement? And so the business problem statement is basically in 4 parts. The middle graphic shows you that the various forms of data we collect, how frequently we collect, and every one of those data is in a silo. There is a group, a project team, which is managing that particular data set. They're managing the logic associated with that. So what that means is that I have decentralized data management. It's not that it is bad, it's just that it is inefficient. We are producing the product, but if I want to enhance the process, I have to address that business process. It prevents me from linking data. It prevents me from getting more analytics done. The next one was the processing. The processing approach has limitations because data processing is inconsistent. So we want to process data. So what Gargi showed is one form of how data is used. We have our own data cycle. We have a data life cycle which matches our survey life cycle. We need to make sure we manage that. We have security limitations. Believe it or not, we are legally bound, and I'll show you a slide of what are the different types of security that we have to operate under. And then finally, technology. Okay? We cannot keep building individual servers, individual storage arrays. We cannot manage all that in our data center. We need to look for new technology that can enable the business side to produce the products faster and better. Talking about security. So, how many folks here in the federal government? Okay? So, you may be aware of this. The first one, we cannot use any environment which is not FedRAMP certified. FedRAMP certification means the environment has to be on US soil, it has to be managed by US citizens, it has to be certified by GSA. Otherwise, we cannot use it. So guess what? That was a form of standardization across the entire federal government. The next one is FISMA. This is the Federal Information Security Act, which demands that we protect all your data. As citizens, we have to protect it. The last one is NIST, which produces the standards. They produce the standards, the security standards of how we are going to manage the data. Okay? So guess what the bottom part is? The bottom part is all the customers. They have laws. So right in the middle, you see or the first one, census, we have a law which says Title 13. If we don't manage data, we are criminally liable. The employees of the agency are criminally liable. So we want to protect the employees and make sure that we don't divulge your data. The next one is Treasury. IRS has its laws. We take tax data, and we use that as part of our process of producing the financial information. Well, that has to be protected per their law. So we have to apply that same law to our environment. We get a lot of health data, HIPAA data. Guess what? There's a law to protect that. And we have to manage that. We are the stewards of that data, so we have to operate that. And then finally, there is a law which says all statistical organizations, so Department of Labor, Department of Agriculture, Bureau of Economic Analysis, all their data is with us. We have to protect that also because there's a law for that. So you can see the security controls, the management of all this is pretty important. And if this day and age, security and privacy is key. We are doing a great job. It's just that we cannot keep sustaining it in silos. So based on the platforms and the architecture patterns that was presented before, the proposal and where we are going is basically we are going to create a data lake ecosystem. And we are going to use this across the board. What we are trying to do is the fact that we are centralizing our capability. We are centralizing our computational environment. We are providing a repository where we will keep the data and the code. We will provide data as a service on top of infrastructure as a service and platform as a service. And then we will allow analytics on top of it. Now, the proposal here is not just to use the Amazon tools, and I don't know how many of you may have attended my previous presentation. We are also wanting to use other open source and COTS products. So we are planning to use SAS. We are planning to use Hortonworks. We are using other products in addition to what Amazon offers so that we can deliver this and have it capable of moving from one cloud provider to another. Amazon provides great services, but we want to be flexible because we want to continue to improve. Census is huge on innovation. We are constantly wanting to innovate and improve. And then the last part also is a content repository with the entire thing is bound by what we call security as a service, which is not an add-on. One of the things is the fact that there is a huge push that, oh, security comes at the very end. Yeah, we want to do authority to operate. We want to do FISMA certification. All that is at the end. And we are saying, no, we are bringing it right up front. We are building it into the system. And we are not going to go back and try to validate, build it for you. It is going to be built once, and we are going to keep improving that security as threats continue to evolve. So the as-is state is the fact that we have today these silos. The way I picture this is, you have your individual houses, and then you become part of a community, an HOA. When you have your individual houses, you have to manage everything. You have to manage the water supply. You have to manage your own garbage collection. You have to manage your doors. While when you then come into the enterprise system, on top of the FedRAMP, which has been certified across the federal government, Census will offer standardized cloud services. We will also offer standardized data services that are targeted for us, and then the individual business entities can do their own analytics on top of that. But we will manage it all in a logical way. Okay? We don't want people to say, oh, we have to convert everything to the same data format. I don't need that. We will provide all sorts of data format support, and that's the whole beauty of big data. I can do schema at read. I can store all types of files. I can convert files using different tools, and I have scalability in compute and storage. Also, they mentioned about Glue. One of the key things here is the notion of we always keep track of the data. We will keep track of every instance of the data when it is changed, but we will not make copies. So if there are 5 groups which want to use the same data, we'll load it once, and we'll allow the 5 people to use it at the same time. So with that, want to open it up. Please let us know if you have any questions. We'll be here, and we can take some now, or we can talk to you after the break session.